I request Dr. Sachin Chavan to again
So I'm
start his lecture and
hello,
share
sir.
his screen.
Sir, I'm not able to share my screen. I think you have to give the permission to me.
Yes, you can share it now.
Okay. So everyone is joined again. Should I continue or sir, should I stop to wait for participant? Should we wait for participant?
No. They have joined, I think. They will join, no problem. You can continue.
Okay. So we were discussing about the Raspberry Pi as a single board computer. So here you can see the more powerful processor is available on the Raspberry Pi, and the plenty of options are there like USB 2, USB 3, then GigaNet, Ethernet. You can interface the internet. Then choice of in memory interface that is 2 GB, 4 GB, up to 8 GB is available, and some other micro HDMI ports if you want to connect the video output, then you can connect here. So this is a very powerful board is available in the market. I request all the participants mute yourself. I'm getting noise. Now, so I have just asked you, instead of using these devices, instead of using the ready-made devices available in the market, you can design your own IoT development platform. Okay, the noise is gone. So by instead of using the previous models which is available in the market, you can design your own board. Okay, so see, I will discuss here how to design that your own board. So just take the first step, that is choose the processor. So while choosing the processor, you have plenty of options like 8-bit processor, 16-bit, 32-bit. Okay, so it depends on the application, you have to choose this processor. But while designing your own board, you don't get any problems while if you are going for the 8-bit or 16-bit. You can design your own board in your laboratory, and plenty of PCB design softwares are available in the free version like Altisim, Mentor Graphics, Eagle, OrCAD, etc., etc. So using that, you can design your the processor designing and interfacing designing, and it is very easy as far as consider the 8-bit or 16-bit. But if you go for the 32-bit, the problem with the 32-bit is that after 32-bit in this range, all the processors available in the SMD, surface mounted devices are there. Okay, so it is very difficult to design a board using the SMD component, and 8-bit and 16-bit available in the DIP packages. So in the laboratory, it will not be a problem while designing. But if you go for the 32-bit, then it will be problem. But my suggestion is go for the 32-bit. Okay, take a help from the PCB designers. Maybe so many our alumni are working in the PCB designing, and if you contact them, they will help you for this designing. And why I'm giving the suggestion is that 32-bit, because in 32-bit, basically the ARM processor, if you take in 32-bit ARM processor, there is a facility that you can shift this 32-bit ARM processor to the 16-bit thumb instruction set. So there is a advantage that whenever the high-end applications you are running, then you can shift to the 32-bit, and when there is no such a computational power is required, then you can shift to the 16-bit processor, 16-bit. So you can use this facility. So that is why just go for the 32-bit. So your IoT system may be capable for low-end application as well as high-end application. So just take the processor, then design one crystal circuit for running this to provide the oscillations to them, then power circuitry, etc. And just connect interface the sensors. That is, take an example like temperature sensors or humidity sensors. Okay, and power supply section is there. Okay, then To visualize the output, suppose you are reading the temperature sensor data, and for visualization, you can interface the 16 by 2 LCD or 16 by 4 LCD. Nowadays, the various kinds of displays are available in the market. Instead of using LCD, the OLEDs displays are also there. Graphics, alphanumeric graphic displays are available. You can you can go for that. Now, instead of displaying here, our main aim of this IoT system, we have to put that data onto the cloud. Okay. So here there is another model is you can external interface, that is ESP8266. Basically, it is a Wi-Fi module. Now you have to interface that model. So here in below figure, you can observe that there is a ESP8266 Wi-Fi module is there. So you need to interface to this microcontroller or any processor. Okay. So now using this 8266 Wi-Fi module, you can transfer this data, or it will get the capability of an internet things. So you can connect this internet and you can put that data onto the cloud. So cloud means there is a server. So on that server, you have to put the data, okay, onto the cloud. And from that cloud, you can access from the many applications are there, like freeboard.in, then duet.in, etc. If as far as consider the Arduino board, as far as consider the Arduino board, you can use these applications while accessing the data from the server. Okay. So this is the basic system is required to for the IoT sensor. You can see the IoT system or connected device or IoT sensor. Okay. So now we shall move to the next one. Now, how this ESP8266 model is work? How work? So basically, this model has a stack of an TCP/IP stack is present on that chip, and is basically designed for the Wi-Fi network. And it contains some pre-programmed AT commands are there. You have to look for the data sheet. According to that AT commands, you can access this ESP8266. And basically, this if you are connecting this 8266 Wi-Fi module to the Arduino Uno board, then this Arduino Uno board have the facility. They have the server, that is ThingSpeak server. So just write the code. The most important thing is you have to write the software while doing all these things. Okay, it may be a Python, it may be embedded C, anything, any language you can use for writing this software. So while reading the data through the ADC, then writing the code, and for writing to display the visualize the data, then you have to write again one function code, and while sending the data through this Wi-Fi module, you have to write the code. So all this code you need to load into this processor. Okay. So if you are using the Arduino board, and then you can put your data through the ESP8266 module to the ThingSpeak server. So Arduino company has given the server facility to the users. They can put their data onto the ThingSpeak server. And after putting the data, you need to create your digital dashboard to access that data. Or data broker is needed to access that data. And this digital dashboard can be designed using the freeboard.io. Okay. So the data is visualized for the users, or from any smartphone or any application, you can access this website, freeboard.io, and this freeboard.io takes the data from ThingSpeak server and is visualized to you. Okay. Basically, this freeboard.io uses the JSON file instead of an .hex file or etc. It uses the JSON file to visualize the ThingSpeak data. ThingSpeak means this is the server. So server's data is visualized on the freeboard.io by using the JSON file. So what is we need to go to the freeboard.io website, and you have to sign up, and you need to create one account there. And after creating the account, you can access data from this ThingSpeak server. But for free versions, you can access some, you have the limitations. But if you are designing the system professionally, then you have to purchase the space from that server. Okay. So everything is not free while designing this system. If you are purchasing the Arduino Uno board, they provide some space to put the data onto the cloud and to access the data from the cloud. But if you want to design a professional system, you need to purchase the space onto the server. Okay. Now this is the system, how sensor nodes and IoT gateway are working. So see, so these are the sensors. Take any sensors. So here three sensors are shown, and these sensors are interfaced with the sensor node. So this is your IoT sensor, maybe you can say that. Okay. So this sensor node may be your Arduino board, or it may be a Intel Jewel board, or any board. We have discussed plenty of boards, 10 boards, and out of that you can use any board here. Otherwise, you can design your own board here. You can design your own board. So it only essential to processor is there. Then IO pins are required to interface the sensors, and it should have the capability to connect the internet, that is Wi-Fi model or Bluetooth model, anything. But here you can see, instead of give the internet capability to this sensor, you can give, there are two options. You can give the internet capability to this sensor node, otherwise you can connect to the Zigbee. Otherwise you can connect to the Zigbee, and that Zigbee transfer the data to the another Zigbee. Okay, and this data is received by the IoT gateway. So this is the another board is there. This is the Raspberry Pi model. This is the Raspberry Pi module, and it acts as an IoT gateway. So the job of the IoT gateway is that it collects the data from multiple sensor nodes. So this is the one single sensor node. Suppose there are some systems wherein we require 100 sensor nodes. So this IoT gateway receives the data from this 100 IoT sensors. 100 IoT sensors. So there are two options. You can use the Zigbee, or you can directly connect the Wi-Fi model to this board and directly send to the through Wi-Fi Raspberry Pi. Okay, so it is clear, I think. Once again, I am saying there are two options for sending the data to the IoT gateway. First one is Zigbee. Second one is the Wi-Fi model. Okay, so here we just discuss the ESP8266. You can connect ESP8266 here for Wi-Fi if you want to give the capability, internet capability. But normally what the users are doing in IoT systems, they're collecting the data, process the data, and send it through the Zigbee to the IoT gateway. Now, why these options is choose? Because these sensor nodes basically work on the batteries. Okay, suppose you are designing 100 sensor nodes and you place these 100 nodes in a different areas. Okay, and it is not possible to give the unlimited power supply to them. Okay? So you need to work, or you need to provide the energy, or you need to provide the power supply from the battery. Okay, and battery doesn't have a long life. Okay, so if you process the data at a very fast rate or perform the most powerful applications here, then battery consumption is more. If your processor works very fast or at a high speed, then battery consumption is more. So to avoid that batteries, to drain the batteries, normally the users what doing, they collect the data, okay, process, make the in packet format, and send that data through Zigbee to another Zigbee to the gateway. Now the IoT gateway has the capability, and it is connected to the unlimited power supply. It is connected to the unlimited power supply. So job of the IoT is collect the all the heterogeneous data which is sent by the suppose 100 sensor nodes. Okay, all these suppose 100 sensor nodes are sending the data towards the IoT, and IoT gateway receives that data and making it in standard format and putting onto the local database or to the cloud. Okay, local database means suppose you have the RAM or ROM options on this on chip RAM or on chip ROM, you can, or suppose there is a RAM is there, you can store the data here. Otherwise you can store the directly send the data onto the cloud. Cloud means server. Cloud means server. Okay, so you can put the data onto the server, like ThingSpeak server has an Arduino has an ThingSpeak server. You can put the data. So this is the how this IoT systems work. Okay. So here I will give one example here. There is a one company called as an Maglab. Maglab company is there which manufactures the IoT sensors, which has the capability to measure the current, voltage, and temperature. They have the analog to ADC has a capability on this board. So they read the data, manipulate the data for the DSP microcontroller, and through the Wi-Fi RF transceiver. Wi-Fi is there, RF transceiver. So RF transceiver And then other interface options are also there. So you can connect the Zigbee, Bluetooth, CAN, Bluetooth, etc. And through all using any one of these, you can transfer the data to the cloud. Okay. So like that, they have implemented some MagLab IoT sensors in fleet and tools. So this is the MagLab IoT sensor which monitors the fleet. Then some MagLab IoT sensors are there which monitors the maintenance, and they collect the data, put the data onto the cloud, and that data is provided to the users. Okay. So there is another application of the MagLab IoT sensor is factory and machinery. These IoT sensors can be implemented in factories to monitor the different parameters or control the different parameters. And it also, these MagLab IoT sensors can be implemented to monitor the health of the machines. They can check the different parameters of the machines and report to the users by putting the data onto the cloud. So this is your cloud. Cloud means server. Okay. Now, there are various applications wherein you can implement this IoT, Internet of Things. So as far as consider the healthcare sector, then home building, then retail sector, then energy sector, manufacturing sector, then logistic and chain management in media sector. So you can observe anything in the world, and after observing, you can feel that I can implement this IoT system here. Okay, so observation is required, and if you got the idea, then you can implement the IoT system. So now we have up to now we have just discussed the introduction of an IoT, then how to design one system and how that system can be connected to the IoT gateway and cloud. Now for these connections, the communication is required, and for the implement the communication, different kinds of protocols is required. So we have some short range protocols, then medium range protocols, and long range protocols. So as far as consider the short range protocols, we have the Bluetooth. Okay. So by using Bluetooth, you can transfer the data, but these Bluetooth protocols can be used in normally used in wearable devices like smartwatches, then smart headphones, microphones, etc. And mostly the wearable devices use the Bluetooth technology. The problem with the Bluetooth is that if you want to transfer the large amount of data frequently, then it is not possible through the Bluetooth. Then another protocol is there, short range, that is RFID, radio identification. Radio identification. So as far as consider this radio identification, mostly used for the obtain the positioning of that object, position of that object. And causes of this radio identification, this RFID is used in chain management application or in logistics, chain management application or in logistics. Take an example, suppose in healthcare sector, the doctors are monitor their patient, the location of the patient through this RFID tag. Or in retail sectors, if you go to the malls, etc., there are various products are there wherein the RFID tag is there. So they are just the RFID tag is useful to avoid the out of stack situation. So RFID is mostly used in retail sector as well as in health sector. As far as consider the medium range, then Wi-Fi is available. This Wi-Fi provides the better connectivity and reliability for the communication. And if you want to transfer the large amount of data, then Wi-Fi is a better solution. But it is a power hungry also. Wi-Fi is a power hungry also. So according to your application, you have to choose a particular protocols. Then Zigbee is again available for you. Now, this Zigbee is used, basically it provides the capability of a mesh networking. Okay. So for me, as far as consider the application, if mesh networking is required, then you can use the Zigbee protocol. But again, it is a low power protocol. It is a low power protocol and also provides a very low data rate. Data rate is also low. The causes of this low data rate, it is used in industries. It is used in industry applications. Okay. So Zigbee is also there. Then as far as consider the long range IoT solutions, then first one is that is narrow band Internet of Things come in picture. And this narrow band IoT provides the extremely low power consumption. And this, it also provides the very good signal quality. As far as consider the 2G, 2G is considered, then this NB IoT provides an 23 dB signal strength. Okay, so signal quality is very good. And then LTE-Cat1M is also there, which connects the IoT and M2M devices. So Internet of Things and machine-to-machine devices, they can be connected together using this LTE-Cat M1 with a medium data rate. Data rate is medium. And these two technologies, narrowband IoT and LTE-Cat M1 technologies, uses a present network infrastructure network. They don't need any new infrastructure. They are using the current infrastructure, and they can provide us solution. Then third one is the LoRaWAN is there, long range wide area network is there, which has again the low cost and also provides the mobile and secure bidirectional communication. Okay, and the bidirectional communication is in the IoT, Internet of Things. Then machine to machine, then smart cities and industrial applications. This LoRaWAN is protocol can be used. Then the next one is the Sigfox. Okay, so basically, whenever the Wi-Fi range is short, we have the Wi-Fi range. Okay, Wi-Fi protocol. So whenever the Wi-Fi range is too short and the cellular technologies, these two technologies, NB and IT, LT Cat1, Cat M1 is a cellular technology, and whenever these two technologies are not sufficient, then Sigfox technology is protocol is used. The speed is about 10 to 1 kbps, and it consumes very less energy. As far as consider the cellular communication, it consumes 100 times less energy as compared to cellular. Then there are some recent protocols are there. You can see. So 6LoWPAN is there also there. And basically, this 6LoWPAN is built on the top of IEEE 802.15.4. So this 6LoWPAN basically works on IPv6. The long form of this 6LoWPAN is IPv6. Okay, IPv6 low power area network, low power wide personal area network, personal area network. So basically, this IPv6 as a successor of an IPv4. Okay, so if you use this technology, a protocol that is IPv6, so it gives you the capability of 10 into 10 raised to 28 addresses. Sorry, not 10 here, 5 into 10 raised to 28 IP addresses. So this much IP addresses we will get through this IPv6, and it is sufficient for the world. So whatever the world population is there, 700 billions, every person in the world can get the each single IP address. Okay, so huge amount of facilities are in IPv6. Then RPL Tech protocol is there. I will discuss RPL in next slide. Then Z-Wave, another protocol available mostly used, that is Z-Wave. This Z-Wave is again low power protocol, basically used for smart home applications or smart home applications. The user mostly obtain this. They are using. Then COP and RPL I will use discussing next. So this one is RPL technology topology. So basically RPL is a distance vector routing protocol. So basically this is whenever the harsh environment is there, means such applications are there wherein the large noise is there, and in that you can use this RPL protocol. It works on the DoTag methods. Basically this is the DoTag route there. It is called as a DoTag route. It is a node. All these are the nodes, and this is a DoTag node. And suppose there's this sensor node. This one is also a node. Want to transfer the data from this node to here. So this DoTag is there, which calculates the path between this DoTag route to this node. It calculates the path. Okay, and according to the objective function, it calculates the path. Okay, and whenever the path is selected, the shortest path is selected, and the data is transferred from the sensor node to the basic route. So how this protocol works. Then 1 minute, I will drink the water. Then another protocol is message MQTT. MQTT, that is message query telemetry transport. Again, this is the publisher subscriber based lightweight messaging protocol is there, and Basically, it is a small code footprint and also a limited network bandwidth for this protocol. And it works in a constant environment. And the constant environment is what? Suppose there are some sensor nodes are there wherein the battery, they have the battery limitations, then manipulation processor is not too strong to perform the manipulations. In that case, this protocol is used, that is MQTT. So it works basically on the publisher and subscribe principle. So what is the publisher and subscribe? Take an example. I will explain you here. And publisher subscribe based topology, but it required a MQTT broker. Now, what is MQTT broker? So basically, it is also a node, but it has a large computational power. Large computational power. It's not your normal sensor, IoT sensor node. It has some. It requires some large computational power because it receives the messages from the publisher, it put into the queue and sending that messages to the subscriber. So subscriber, nothing but your clients. Subscriber, nothing but your client. So those subscribers or clients subscribe to the topic. So this publisher sends one topic. This publisher publish the topic name. Now, and after publishing that topic, these subscribers or client subscribe that topic. Subscribe that topic. Take an example. Suppose publisher publish the topic name speed. Publisher publishes the topic name speed. And suppose there are multiple clients are there, and these clients subscribe that topic, that is speed. And this one is also subscribe for speed. Now, whatever the information is coming or published to related to the speed, this subscriber or client will get that information. Suppose the speed is about 50 km/h. This is the information. So these clients will get this information because they have subscribed to that topic. So this one will get 50 km/h, and this one is also get 50 km/h, like that. So according MQTT broker just check the topic name, and those have subscribed that topic, this MQTT broker transfer the message to them. Then another protocol, that is COP, is there, constant application protocol. Basically, it is again a lightweight fast HTTP protocol, and again it is used in constant and node network. So I already discussed what is constant means. Constant means it has limited battery power and limited processing power. So here, those are have the constant environment COP. They are connected to the COP server. Okay, and from that COP, one proxy server is again used, and from that proxy, the rest is communication done by the HTTP. Rest communication is done by the HTTP hypertext terminal protocol is used. And here in this COP basically built on the TLS and DTLS. Maybe these technologies are not aware to you, but I have to explain to you TLS and DTLS. In this diagram, you can see here, this COP is built on this TLS and DTLS. So TLS means transport layer security, and DTLS means datagram transport layer security. So COP is built on these two, and here this COP builds on these two, and both these protocols uses the UDP instead of an TCP/IP. They are using the UDP, user datagram protocol, and this UDP is used causes of an security. Causes the security. So security, as far as the security is concerned, then COP is mostly used. So after there are plenty of protocols are there, and according to their applications, according to the application, you have to select a particular protocol. Then M2M and IoT concept is there. M2M means machine to machines. So basically there are some protocols are there which is in machine to machine, and these machine to machines work they are using the wired network as well as wireless network. So see, in this diagram you can observe that this is machine to machine area network is there. All these are machines exchanging the data, but they are not using the IoT. This M2M actually not using the IoT, internet is not using. they are using their different protocols like I2C, Modbus, etc. So these are the essential protocols. If you want to work in industry, then you should be aware of what is I2C and what is Modbus. Okay. So this machine to machine uses the I2C and Modbus protocols in there for the exchanging the data. Now, suppose this M2M network is want to connect to the external network. So there is another network called as a wired network. So all these are connected through the wires instead of this protocol. So M2M gateway is used to connect these two networks. The M2M gateway is used, and finally the data is transferred to the user end. So sometimes the wireless technology is also used for connection. So this M2M wired connection is connected to the wireless network. So again, M2M gate is required to transfer the data from one M2M network to another network, and finally the data is sent to the user end. Okay. So how this M2M works, machine to machine. So basically it is machine to machine is the vast topic. Now there are some differences between the M2M and IoT. How these different we shall discuss. So basically it is point-to-point communication usually, but here in IoT they uses the IP networks, that is IP addressing, and varying communication protocols are used. So varying communication protocols means MQTT, COAP, ZigBee, etc. Then this MTM, that is basically emphasis onto the hardware, and emphasis means basically focus onto the hardware. And here in IoT, the IoTs are mostly focused onto the software. Okay. And as far as consider the applications, so the vending machines, ATMs, and smart meters are the examples of the MTM. And then smart cities, offices, homes, and connected cars, all these are the IoT devices. So as far as consider their architecture, so you here a link layer is there, then network layer is transport layer and application layer. Okay. But here as far as consider the M2M, so machine to machine will work in link layer and network layer, And as far as consider the IoT, so IoT basically works here, transport layer and application layer, mostly work in transport layer application. But if you take this part, then you can see this is the IoT architecture. So IoT architecture uses link layer, network layer, transport layer, application layer. This one is also same. If you take this whole 4 layer, then it is link layer, network layer, transport layer, and application. This is your IoT. But machine to machines are working only in 2 layers, link layer and network layer. So now we shall move on to the industrial IoT requirements. So industrial Internet of Things refers to the extension and use of Internet of Things in industrial sectors and applications. Presently, the information technology and operation technologies are used, that like the SCADA, PLCs, ICs, etc. Okay. So to increase the production and efficiency of the industry, you have to use the IoT in industrial sectors. So here there is a concept is coming right now, that is Industry 4.0. Okay. So now I'm not going to discuss whole Industry 4.0 because again this is one is an vast topic. I have taken here because this Industry 4.0 has an Industry 4.0 has an Internet of Things. See, so IoT is a basic foundation of an Industry 4.0. Okay. So along with the cyber physical systems, the Internet of Things network is used in Industry 4.0. So in what is Industry 4.0? Basically it is a generations. Firstly the Industry 1.0 is came, wherein the mechanical and steam powers is used. Then Industry 2.0 came, wherein the mass production is done by the electrical supplies. The electrical power supplies are used. Then Industry 3.0 is came, wherein the automation, computers and electronics like SCADA, PLC, etc. are used. And again, now the Industry 4.0, that is basic foundation of this Industrial 4.0 is IoT. That is why I have chosen the here Industry 4.0. Now, basically, this term Industry 4.0 is came from the Germany. Okay, so Germany country actually their government trying to implement all their factories into the Industry 4.0. So, what is Industry 4.0? Industry 4.0 is nothing but they are making their industries smart. They are making their industries smart, like smart people, smartphone, smart devices. We are saying everything is smart, but not in smart factories. So, like that, they are trying to implement all these smart factories. Now, what will be the advantage of that? So, I will give one example here, and then we will conclude this Industry 4.0. So, take an example. Suppose you are going to purchase one car. Okay. So, while purchasing a car, suppose take any manufacturer, take an Maruti service, Maruti. They are providing the four options. So, one basic model is there, and one top end is there. So, four models there continuously. Any company actually manufactures the 3 to 4 models. Okay, and the user have choice. They have to select out of these four. Okay, and this is the current scenario. But if you go for the Industry 4.0, and while implementing the artificial intelligence and Internet of Things in Industry 4.0 or in industry, the experts are saying that these car manufacturers have the capability. They can manufacture the car according to the users, according to the multiple users. So according to your requirement, they can manufacture your car. According to your requirement, they can manufacture your car. So instead of these four models, they can manufacture the cars according to the user expectations. So this much capability will get in the Industry 4.0. And the basic thing is they are all these built, these advanced factories built on the Internet of Things. Okay. So this is the current standard. Now you know the what is IoT, Internet of Things, brief introduction of an Internet of Things. Now you know how to design the systems, and you also know the how to connect that system using the different protocols. Okay, now you know the what is Industry 4.0 and why this advanced technology is needed. It is the need of the hour of the industry. Advanced systems are required to implement it. Okay, so I have to focus on to the implementation, how this system can be implemented in industries. Okay, sir, I have more slides. Is it okay or continue? Should I continue? I think I will require at least 50 to 20 minutes.
How many slides?
I think I have still 20, 50, 25 slides are there. So what should I do? Should I continue?
I think still 10 to 15 slides are there.
I will require another 20 minutes, sir.
Yes.
So
you will have to rejoin again.
Rejoin.
Rejoin the meeting.
Time?
Yeah.
Okay. So I'm just stopping here, and I will rejoin it.
Yes. Still only 1 minute is left. So we'll have to rejoin again because still 10 to 15 slides they are remaining. Okay. So it will take at least 10 to 15 minutes for him to explain that. So I request all the participants again to rejoin the meeting with the same link. तुम्हाला म्हटलं होतं मी डबल होणार. नाही हे काय होईल रिस्पॉन्डच करू नॉट रिस्पॉन्डिंग. तुमचं हे बंद केलं काय?
बंद नाही स्टार्ट म्हणा की
कुठे स्टार्ट हे स्टॉपच होईल ना फिरायला लागली. There is some network issue.
नेट केलाय का बाबा नेट चालू आहे ना नेट चालू आहे ना
ठीक आहे.
चालू आहे रेडमी कनेक्ट चालू आहे स्टार्ट करा की
हे फिरायला लागले नुसतं नॉट रिस्पॉन्डिंग झूम इन नॉट रिस्पॉन्डिंग झूम नॉट रिस्पॉन्डिंग बहुतेक नेटवर्कचा प्रॉब्लेम आला. दुसरं कुठलं आहे तुमचं रेडमी 4 आहे का? हे का
Wi-Fi